So the project incorporates the femur in a custom-made jig, which is currently held within this compression testing machine. This is a Tinius Olsen 150 ST, and it can mimic tension and compression to a predetermined force. This is our independent project in relation to the strain analysis of the femur bone during the gait cycle. So essentially the gait cycle is how an everyday person would walk. There are several main phases of the gait cycle. So with this femur, it's an artificial femur in which we have clamped into a custom-made jig. So this jig here has been printed on site at West London IoT using a 3D printer, and it took about 2 weeks worth of designing and printing in total. And what this machine is doing, this is a compression tester. This is currently mimicking the forces experienced during the gait cycle. So it is currently oscillating between 3,000 newtons and 500 newtons, in which this machine will take those readings and transfer them over to the Hardness software, and it will record graphically the mapping of the forces experienced. Determined force is governed by this software, which is Horizon software. This is directly communicating forces to the compression testing machine, and there are two graphs which represent the force against the position and force against the time frame allowed within the software. This is an impact testing machine. It will measure the energy dissipated through the material, which will be governed by this hammer. We've got a few samples here. We have brass, aluminium and steel, and I'm going to demonstrate how this machine works with a brass sample. So the brass sample will have a cut V groove, and that will slot in a specific place between the jaws, which are situated down there. So here we have two readings. So the first reading is 408 joules, which is an energy unit, and that is contained within the hammer setup. As the hammer swung down, it hit the sample, and the sample consumed the second reading, which is 10.6 joules of energy. We can then use this information and alter the temperature to create a DBTT graph. So this will be a ductile, brittle, transition and temperature graph. So we can either warm the sample up to above room temperature, or we can use liquid nitrogen to lower the temperature. Overall, this machine records the energy absorption, which can be used in the real world, for example like a high-speed crash, such as car bumpers, which are subject to high strain. Particularly useful when high fracture mechanics are experienced, so that would be in the ship sector due to temperature variations of the sea. Can also be used for materials for airplane technology.
The hardness testing machine, which is used to find the resistance of the surface of a material. There's three types of tests that can be performed using this machine, which is Vickers, Brinell and the Rockwell test. Each of the test types are different because they have different intenders.
As you can see, it has a ball shape, and here we can see the value for the Brinell testing. It's HP 2.5, 187.5 for this part. And if we are going to move in a different place, it's gonna change, because it depends if the material is clean, if has any deformation, any other issue, or